everything that you see in this view is actual data. Okay, these are at the top row. These are the variable names. Variable names. So we have the gender. We have another variable called gender recoded, university, year, social media, family and friends, etc. Okay, so what you see at the top in the data view is called the variable name. It's called the variable name. Now we also have the tab that says variable view. Lower left corner, there is what's called by variable view. If you click on it, you will see at the first column, these are the variable names. So case ID, gender, gender recoded, university, and year in medical school. So we have data view and variable view. Now, variable view does not have data, it has the characteristics of the data. Variable view does not have data, but it has the characteristics of each and every variable in the data. The variable types you've taken second year by stat, you've taken the variable types. So if we look at the variable that's number 3, which is gender, it's a string variable. String يعني text, يعني gender is male and female, male and female. So the option answers for this question is called male or female. So it's written in letters, male or female. Okay. Now, SPSS does not like to deal with text variables. String means text variable. So I have recoded it to be numeric. So I have gender and gender. They are both the same, but one is a string text, one is numeric. If we click on number 3 here next to the gender, it takes us to the data view. Takes us to the data view. So I have gender and gender recoded. It looks the same. Subject number 1 or ID case 1364 is a female in gender, and gender recoded, it's a female. Okay. Now if we go up here and click what's called by data labels, you'll see that data gender recoded is not actually a text. It is shown as a text, but the actual data for it is numeric. It's numbers. So the term female corresponds with number 1. Male corresponds with number 2. So the data is actually 1 and 2, but I have labeled it to say 1 is female, 2 is male. 1 is female, 2 is male. Okay. How can you label a variable? Labeling a variable. Now, when I say variable, it's actually the question. It's actually the question. So when I say variable gender, then the question behind it is what is your gender? So this is something has to do with variable characteristics. So if we go to the variable view, lower left corner here, if we go to the variable view, we see gender and gender recoded. Gender is a string variable. Gender recoded is a numeric variable. Okay. If we go all the way, under label, Under label is the description. You can put the description of your question. So here we can do, why don't we use this? What is your gender? The label in here, in the name of the variable or the name of the question. Again, when I say variable, it means question. Now, the name of the variable is actually used into the analysis compartment, into the analysis part. So any space will not be allowed. We try to remove the underscore and hit space, hit enter. It gives you variable name contains an illegal character. So it does not take the variable name, or the variable name does not take spaces, does not take special characters, does not start with a number. This has to do with the way the data is being processed for analysis. Okay, it's like a coding, and the coding doesn't like to have the variable name starting with a number or any spaces between them. So far I have the name. In the variable view, I have the name and I have the label. The name of the variable is gender and gender recoded. Under the label is what I need to call this variable. So what is your gender? And I can add recoded here. What is recalled original? We go back to the gender. Click on the type of the variable. We will see all the types of the variables that we can use. One of them is numeric, the other is string. These are the two main variables or variable types that we actually can change it into numeric, but we will lose all the data within that specific variable because it will convert the text into numbers. It will remove the text, remove all the letters, and keep the numbers. So everything's going to be missing because the variable gender is male and female. It will be removing all the letters. Anybody has any question so far? Okay. So far what we learned is that we have data view, which we will see all the data, variable view, which we will see the variable type and variable characteristics, variable type and variable characteristics. What other variables we have? We have, for example, university. If we highlight university or click on number 5, it will take us to the variable that's called university. And if we right click, sort ascending or sort descending, we'll see that we have more than one university. Al-Balqa Applied University is the first one. Keep coming down. Then we have Hashimite University, Jordan University, and Just. Okay. There should be Mu'ta University as well. Mu'ta University. So we have 5 universities. Okay. Let's go all the way up. One of the most important things to add to your data is what's called by case ID. Case ID is a specific, unique number provided to each individual. So I'm now at the data view, line number 1, or let's say line number 2, the highlighted line has case ID 833. This is the timestamp, which is the time the subject filled the survey online. The subject is male. Male number 2 from Al Balqa University, fourth year medical student. And has he ever used social media as a main source of information for COVID? This is what's called social media. This is never. And then we have the answers to each and every of his. Let me go on and open a new data set. You don't need to do that. Let me just do it myself. A new data set, it has no data. Okay. See, all the variables at the top are called VAR variables. When I'm using a new data set, I have to start with the variable view. And under variable, I can say case ID. It doesn't have to have the same exact terminology, so it doesn't have to be case ID. It just could be number. Student number is fine because your numbers are unique. Each student will have only a number, one unique number. So the variable name will be case ID. Then we can say gender, school, for example, university, unlike university because there was a space. So if you hit university space, it's not gonna like it because it doesn't take spaces. University. Now it takes the type as a numeric value into default. So you can only enter numeric values. Okay. If we go to the data view, we'll see that these variable names that I just entered are at the top. You can mix with them. So the first subject here is ID of 1, gender, let's say M-A-L-E, male. It didn't like the male because the male is a text, it's a string variable, and it only takes numeric values. We go back into the data view, I'm saying gender is a numeric value. Okay. If you want to keep it as numeric, then you have to have a sheet and you say 1 equal male, 2 equal female, or you can say 1 equal female, 2 equal male, or the other way, whatever you want, as long as you know what the numbers mean. So let's say 1, school is as well is a numeric value. So school means faculty, for example, nursing, dentistry, medicine, art, science, whatever you want. So let's just keep this as 3, for example. And then university is going to be the name of your university. You can't do text, you have to do a string. 2, 4. Now 4 has an actual meaning. So this case number is 1. Gender is 1, which means male. School equal 3, which is, for example, nursing. University is 4, so it means he's a just, for example. Now, how can we define these numbers? How can we actually read them as text instead of just numbers? If we click on any of the variables at the top here, it'll take us to the variable view. Under variable view, we have gender, it's numeric. And this is what you need to have as the question, what is? Okay. And this is versus values. For the variable gender, values, the value that we will see in the data is 1 and 2. 1 and 2. So 1, we said we're going to have it as a male. 2, it's going to be female. Go to the data view, click on value labels. This will change. Do the same for school. school. Here we can say one is just is Yarmouk University, University, or will be University. So now we have a new data set that has, we've introduced the concept of label and we've introduced the concept of values. Now, if we go to the data view, lower left corner, data view, you'll see that it took all the values of the label, but it didn't like. This is for school, sorry. So I made a mistake. I did the values for universities at the school variable. So if you go here, copy, paste, change this into one is medicine, is art, as in see how things change in the data view. Okay, so it was able to read the gender, school, and the university. Okay, it was able to read them into numbers. We can then add the values of these numbers, the labels. Okay, so let's go back to the original data set. Now, let's do a simple analysis and see what's going on with the data. Before doing this, I'm just going to write male. See this male here? I'm just going to write M-A-L-E, small letter. Either in the data view or the variable view, if you go up top, analyze, descriptive statistics, frequencies. Now the menu may change between what I have because I have, I think, version 23 or 24 and you have 26, but you need, it's going to be almost the same basic characteristics of SPSS. If you go to analyze and then descriptive and then frequencies, okay, and you do this variable, which is what is your gender. See, what you see in these boxes is not the variable name. Pardon me. You are not seeing the variable name, you are seeing the label. So you will see the actual question that you have entered. Now, if there is a missing label, it will give you the actual name of the variable. Now, the name of the variable could be a little bit complicated. That's why you actually play with the label. You can change this to show the variable name. If you wanted to show the variable name, you can do this. You have no problem. So we want to analyze. Let's go back and do analyze descriptive statistics and frequencies. We want to see the percentage of male and females that we have. We click on the variable that we want. In between the two boxes, we hit the arrow. It'll move from this box to this box. We want to see the other variable. We want to, oh, sorry, gender, university, and year. So what we have done so far is picked up four main variables. We want to see them or analyze them. And then you hit OK. Anybody has any question? Hit OK. So what we did, analyze, descriptive statistics, frequencies, the variables are still here. Nothing has changed. You want to change these, you want to take to the default, you hit reset. If you hit reset, this box is going to be empty. So let's do gender. If you double click on it, it'll jump. University, medical. If you want to take it back, you hit the arrow, it'll go back. Okay? You hit OK. So this is what you see. You have a new window popping up, and it will give you first the code. So what we did is, where do we have it here? For those who can write the code, what we did is frequencies, variables, gender recoded, university, year, MED, and we've analyzed that. What we have, the first one is a description of all the frequency formula that we did. We did a frequency for these four variables, and this is the number of missing cases. We have no missing cases. This was a survey you did online. We don't have actually any missing cases. So the question, what you see is the label. Let's go back. What you see here is what is in the label. If there is no label here, it will give you the name of the variable. So when you do analyze, when you do data analysis, it will show you the name of the variable, the label of the variable, not the name of the variable. So what is your gender? We have gender that's called female, F is capital, and then we have a gender that's called male, M is small, and then we have a gender that's called male, M is capital. This is the problem with the string variable, the text variable. Text variables, they are specific to each and every string. So male with a small m is different than male with a capital M. We have one case of that's male with a small m. We don't care for it. That's why we use numeric values. Numeric values, what you see is it should be here 1 and 2. Remember, female was 1, male was 2, and what we did here, with the values, we've asked SPSS to remove or to change the name of 1 into female and the name of 2 into male. So SPSS will deal with it as actual values when doing the analysis, it will show it to you as male or female as the label. Okay. So we have 835 females, 596 males. The percentage of females is 59.5. The males is 40.5. This is called the valid percent. Valid percent, we don't care for it at this stage, but valid percent will make sense when you have missing values. If you have missing values, valid percent will remove the missing values and give you the total out of the actual values, ignoring the missing. Cumulative percent, it will add the percentage to the one before it and give you a total, okay? So we have almost 2/3 of students are females and 40% are males. So 59.5 are females, 40.5 are males. Now, university distribution, Al-Balqa University, it has 116 participants or subjects or students, representing 8.3%. Hashimat University, they have 193, representing 13.5. Jordan University, they have like 40%. Just has 25.8%. Muqta University, they have 4.4%. Yarmouk University, they have 8.4%. Now, we've distributed this to medical students, and this is how they answered. And actually, these percentages, the percentages, I'm not talking about the numbers. If we take all medical students within these 6 universities, we will have almost equivalent distribution by university. So this is a way to see if your sample was actually random. Now, medical students, I think females could be more than males, or this percentage could be fine. Now, if I do a survey among medical students and I get 90% males and 10% females, I'm talking about percentages, not numbers. If we get 90% females and 10% males, then females probably filled more surveys than males, and it doesn't represent the actual distribution, the actual percentage of the students, all the students. Now, when I say all the students, this is called the population, and I've taken a sample. So I want to see if my sample represents the population. I will look at these numbers. I will look at these numbers. Now, the higher the sample size, then you will have a more actual representation by gender. So if I'm taking a sample size from Jordan, and we do like 50,000 sample of individuals or 50,000 households, the distribution of gender will almost be equivalent to 50%, 50%. If I take the whole population, it's probably going to be 50% to 50%. So the higher the sample size, the higher the number of participants in your study, gives you an indication of the actual distribution within the population that you are studying. Medical year, so this represents the year, current year in medical school. Let's go back and change this. We said we want to change year, MED year. So this is going to be current year. We're going to change here. This is something that I've already analyzed. It's not going to change here. Okay, I did this twice, that's why I have two. Now, this window is different than the data view, variable view window. You can see the outputs that you've done. We've done the first one. We did the frequency distribution, which is here. And I did it twice. I don't think you've done it twice, but I did it twice. This is the second frequency distribution. This is the frequencies. This is the title, notes, statistics about the whole process that I did. And then the frequency table, which has a title, and then what is your gender, what is your gender recorded, university, and medical year. You go back to the data set, hit analyze, descriptive, frequencies, okay, current year at mid school. So I change the label, it will change the actual presentation of this table, okay? If you double click on this table, it'll open a new window. But you can change the text within it. I've never used valid percent or cumulative percent. These two I've never used. I've only used frequencies and percentage. وهذا السؤال ما فهمته أنا. نحط كرقم تقدر تحط الرقم يلي بدك إياه صح؟ طيب دكتور المش مثل string. هلا الفاريبل type we try to avoid string variables. String variables are hectic, they're hard to deal with. And if you have a space, it will give you a new variable. So if we do male space, it's going to be different than male. Male with a capital M is going to be different than male with a small m. That's why we try to avoid this and have numeric values. Now, numeric values, we say 1 is female, 2 is male, and then we say, we label number 1 and we label number 2. Sometimes you have to deal with it as a string variable if the answer options are a lot and you want to just look at the distribution of participants. If we have, for example, more than one faculty, أكثر من كلية بالجامعة, we can use the string type to see how many faculties we have and the number of faculties that we have. So let's go back and do frequencies. We can do a reset. We'll go back, and in social media, if we hit control, so I clicked on this, hit control, click the one below it, okay, click these four, what I did, I entered social media, family and friends, anxious, and this is a question that is, where do you get your information about COVID? Is it social media? And it says all the time, never, and rarely. So medical students who self-reported that they get their information about COVID from social media all the time or most of the time represent almost 40%, 37.5. So more than 1/3 of medical students get their information about COVID from social media, where most of the medical students never and rarely get their information about COVID from family and friends. Never is 40%, rarely is 40%, that's 85%. So 85% of medical students do not get their information mainly from family and friends, information related to COVID. Now, I am anxious of getting COVID-19. Almost 1/4 agreed with this, 26.4. Almost 1/2 were neutral, and almost 1/3 disagreed. I'm anxious that one of my family members will get COVID. So more than 3/4, 78.5% said that they are anxious that one of their family members will be getting COVID-19, will be getting COVID-19. So here what you see is numbers, and then you have to write about these numbers. So if we look at this percent, it's 78.5. 78.5 is a little bit more than 3/4. So I can say more than 3/4 of medical students. Now I have medical students here, but you also can say more than 3/4 of the sample, more than 3/4 of the participants reported that they are anxious that one of their family members will get COVID-19. Once you are done with this sentence, you can write the number 78.5 between parentheses. Okay? Sometimes you need to write this number. So n equal 1102, 1,102 students, and the percent was 78.5. 78.5. Analyze descriptive statistics, frequencies, and let's look at let's do a reset. Buying a mask, buying an air doctor, wearing a mask, washing hands, use disinfectant, pay attention to hygiene, avoid contacting others, pay attention to diet, disinfecting your phone, avoid public gathering, stay at home, avoid eating outside, and avoid shaking hands. If you select all these, avoid kissing and avoid public transportation. So if you click on these, okay, this is one way to do it, or you can just right, double click on it, double click, jump. Okay, we want to analyze all these. This is the first table, which will give you the big picture about the data and how many were actually analyzed and how many were missing. So this is the percent of students who reported buying a mask. To only 13%, almost 14% of students reported that they often all the times buy masks. Buying an air doctor, 33.1% of students reported that they often all the times will be buying an air doctor. These I don't care because the term used is buying, and I care for wearing a mask. Masks. Wear masks. This is a questionnaire for medical students. So if you think almost two-thirds of students reported that they never wear a face mask. Two-thirds of students. Okay? Washing hands regularly, almost all the time, 87%. 87%. So 87% reported that they'll be washing their hands regularly. Using disinfectant, more than two-thirds. You have 68.8% of medical students reported that they will be using disinfectants. Pay attention to personal hygiene, 84%. So almost the majority of students said that they will pay more attention to their personal hygiene, avoid contacting with certain groups of population. 62% or 63% reported that they will often, all the times, avoid contacting certain groups of the population. Pay attention to balanced diet, only 30%. So almost two-thirds of students reported that they would often, all the times, pay attention to their balanced diet. Cleaning, disinfecting the cell phone, almost one half or almost half of participants or almost half of students, which is 46.2%, reported that they often, all the times, be cleaning, disinfecting their cell phone, the screen of their cell phone. Public gathering, almost three quarters, 76.0%, said that they will avoid public gathering all the times. Stay at home, 83.1%. Avoid eating outside is 69.7%. Avoid handshaking is 68%. Avoid kissing, 79%, almost 80%. Avoid public transportation, 70%. 70%. Now, let's see about these variables. If we look at this variable, concern, cautious, 1. This is the name of the variable. And the label for it, since you've heard about the first infection in Jordan, okay? Have you been concerned, cautious, and or preventive? The answer options for it is, I am concerned and cautious. I became obsessed. I changed my diet, my daily prevention behaviors. I don't care at all. I have been concerned but not cautious. Let's do an analysis for this variable, and we said this is concern, cautious 1. Analyze, descriptive, frequencies, reset. Now, concern, if you click here and then do CON, concern, like this, concern. Oh, this is not the question. So this will show you the label. It will not show you the question. So the question starts with a C, concern, but the actual one says sense. So start with an S. So if you click here, hit S. Since you've heard about the infection in Jordan, this is the question we're looking for. That we are looking for, which is before university year recorded, and then so I am concerned and cautious. You have 638 students reporting, self-reported that they are concerned and cautious, which represents almost half of the participants, half of the sample, half of the medical school students surveyed. So 50% of students said they are concerned and cautious about COVID-19. Okay. Now this is interesting. The obsessed ones, obsessed by preventive measures, you have 6.8% of students are obsessed with preventive measures. Almost one-third reported that they changed their daily preventive behavior. 3.1% said that they don't care, and 13% said that they have been concerned, but they are not really cautious. So this gives you an indication about the behavior of medical students within the COVID-19 era. Obsessed, 6.8%. Obsessed people probably went and bought masks, gloves, even air doctor. Concerned and cautious is the majority, so almost 50% of the sample reported that they are concerned and cautious, which is a typical behavior for medical students. 3% reported that they don't actually care, which is scary. Let's go back and do anxiety. Anxiety recoded, worry or recoded, depression. Depression recoded, panic, control, panic, loneliness, nervousness, happiness, joy, excitement, insomnia, shallow sleep, nightmares, insufficient sleep, depression or argue with others. So pick these, starting with anxiety. Pick whatever you want, and let's see the behavior of medical students. So if we look at the left, this is where we started. It'll take you to where we started. Anxiety. Almost 50% of medical students self-reported that they have increased anxiety after COVID-19. Now, this study was conducted March 17, 18 until 23rd, so there was no lockdown in Jordan. Medical schools were off, medical students were off, no schools, no universities. So this is something to give you some anxiety, stress, depression, some mental health problems, emotional changes. And as you can see, anxiety, 50% of participants reported that they have more anxiety. These two variables are the same. It's just the fact that their coding has changed. So instead of decreased, did not change and increased, you have less, neutral, same, and more. Worry, 70% they increased the level of worriness for them. They got more worried. Depression, 23% self-reported increased level of depression. Panic, 22%. Reported they have increased panic. Loneliness, 35% increase in loneliness. Nervousness, 38% increase in nervousness. Happiness, they were less happy. So 44%, almost half of the sample reported being less happy or decreased their happiness level after the lockdown. Joy, 47% reported they have less joy. Excitement, less excitement reported by almost 45.1. Insomnia, 12% reported having insomnia. Shallow sleep, 13% reported having more shallow sleep. Nightmares, 10% reported having more nightmares. More nightmares. Insufficient sleep, 12.3%. Okay, this gives you an indication about some of the emotional changes that are going on within the medical students. So by now, you have the data. You have the variable view, you have the data view, and you can start doing some simple analysis. Now, if I want to look at the numbers for just students only, okay? I have a variable here that's called university, and I have a variable here that's called university. Okay, what's the difference between these two? Let me see. Reset university. This is the first one. The second one is up top university. So I have two variables, one that's called university and one that's called UNIV. Two variables. If you look at them, there's a letter A here. Okay. So this is going to be string variable. This is going to be numeric variable. If I do analysis for them, they are the same, but one of them is actually the UNIV has been recoded. So I converted these into numbers. These, the answer options. So these are the labels for the question, which are the answer options. So university could be Balqa, Hashimite, Jordan University, Just, Mu'ta, and Yarmouk University. Converted them into one, Hashimite 2, Jordan University 3, Just 4, Mu'ta 5, Yarmouk number, I gave it number 6. If we go back at the data, variable number 34, if we hit the values for that number, you'll see that I've assigned a number to each and every university. Okay, Jordan University of Science and Technology is number 4. So Jordan University just is number 4. Next, to analyze, there's what's called transform, and there's data. So analyze is when you want to do analysis. Transform and data if you want to work with the data. If you want to create small sample sets, take a sample, pick a sample, convert university into UNIV, give it, assign it numbers. This is where you do it. What I want to do is split file. Hold on a second. I want to split file. Yeah. So if I do data, split file, and I want to go to the variable that is university, this one. I want to look at the distribution of these emotional changes for each university. So I want each university to have a separate analysis for all these variables. What I did, data, split file, and organize output by groups. So what is the variable you want to split this data into when you perform the analysis? And I want to do university. So what's going to do is going to take each and every university and do analysis for it by itself. Whatever the analysis that you want, it will do it for that, for each and every code within this university. So university has 1, 2, 3, 4, 5, 6. It will take number 1, do whatever analysis you request. Take number 2, do the same analysis. Take number 3, do the same analysis. So let me do it again. Data, split file, organize output by group, and then university, click OK. Nothing has changed. It just said I will sort cases by university. It will sort them by university, and then it will split the file when you do an analysis by that variable. So I want to now do the frequency distribution, frequencies. I want to do, for example, anxiety, worry, depression, panic, and loneliness, nervousness. Okay, you can do it like this, or you can do double click, worry, double click, depression, double click, panic, loneliness. Hit OK. We look at the left corner here, you see that it did the analysis for each and every university. So this is Jordan University. The percent of those who have more anxiety is 46.6. More worry is 72%. 20% have more depression. Panic, 22% have more panic. Loneliness, 34%. This is you guys. Medical students adjust 52%, 53% reported having more anxiety, 75 reported having more worry. Depression was reported by 25%, panic by 25%, loneliness by 48%. Malta University, the same, 50% anxiety, 60% worry, depression 20%, and panic 16%. Yarmouk University, 50%, 77%. Worry, depression is 22%. Panic, 24%. Loneliness is 32 or 33%. Okay? So what we've done is we've organized the output, which is the analysis compartment or analysis part, by one variable. So we take that variable, we understand how it's being organized. One, what does it mean? Two, three, four, five, six. These are each for the name of the university. And then we do data, split file, organize output by group. And we put that variable here. What will be doing is it will do the analysis, perform the data analysis for each and every category for that specific variable. Okay. So you want to convert university and university. Let me get the. So if I click on number 34, which is the variable university in a numeric format, pull it all the way up, 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 pull it under university. So we have here, we have two variables. We have university and UNIV. These are two different variables. One of them is string and one of them is numeric. How can I change this variable to look as if it's a numeric value? So what I do is I go to transform, automatic recoding. Okay, transform automatic recoding, and I'll say I want this variable, which is the university variable. I want it to have university numeric. You can call it whatever you want. So I want to convert the values within university, which are the actual name, which are the string values, into coding 1, 2, 3, 4, add a label to each and every answer option. So each university name will have an actual number assigned to it. Okay. So what I did, transform, automatic recoding, take university, and add, I said UNIV. You can write whatever whatever name you like for that variable. So this is the name of the new variable. It's going to be university and you see the question marks here, and see you can't even click OK because there's something missing. You've taken the old variable. You have to assign a name for it. We assigned a new name for that variable, but we didn't click add new name. When you add new name, these question marks will be converted into university numeric, add new name, and then the OK you can click after that. Okay. Okay. This is what happened. So it took the variable that you assigned it, the old variable, Al-Balqa University, it gave it a value of 1 and labeled that value as Al-Balqa University. 2 is Hashemite, 3 is Jordan, 4 is Just, 5 is Mu'ta, 6 is Yarmouk. So if we go back to the data, the new variable will be all the way down. So it did create a new variable called uni numeric. It's a numeric value as a label of university. And this is how it assigned these values. 1, the value 1 was given to Al-Balqa University. 2 was given to Hashemite. 3 was given to Jordan University. Okay. Now the old variable has only the name of the university. It assigned it to a new numeric value. It will use the numeric value to do the analysis, but whatever it's going to show you, it's going to be not this value, but the actual text. So for you, these two variables could be the same, but in reality, one of them is numeric and the other one is string. The other one is string. So if we do analysis, descriptive statistics, frequencies, the new variable will be all the way down, reset, go all the way down, university, and do OK. This is the variable. So we've converted a variable from being a string into numeric variable. Yes, you can create two variables. You can combine two variables into one, but in SPSS and in statistics, you want to have a split variable so you can deal with the analysis part. Okay, so if you want to do university and medical year, okay, at university you have one of the answer options labels, which is just. Now just has year 1 to year 6. So you have 6 universities and 6 years of medical school. Okay, if you want to merge these two together, instead of having 6 categories or labels for each variable, you're going to end up having 36 answer options. So the new variable, for example, which includes the year and the school or the medical school, it will not have 12 variable, it will have 36 answer options. So for example, it will have just first year, just second year, just third year, just fourth year. So the answer option is going to be, or the label is going to be 36. And what you need to do is have raw data. So in data analysis, we deal with raw data, try to make sense of data. We ask one simple question. That's why the questionnaires that you see are lengthy, because we need to ask one simple question each time. We don't ask two questions, merge them together, because it's not going to make sense when you do the analysis. Okay? Now, whatever you do not do recode into same variable. So we have transform, recode into same variable, and let's do the new variable that we've created, this one. So I want this variable, I want to recode it, but it's going to be the same variable. I'm not going to recode it and create a new variable from the old variable. Now this is a tricky thing, because once you recoded the variable using recode into same variable, then you have changed the variable for good. Nothing that you can undo. That's why we try to avoid doing this process. We try to recode into a different variable. So take the old variable, create from it a new variable, and work with the new variable. If you have a mistake in creating the new variable, you can just delete it, because you have the original variable. Now, if you have the original variable and you've changed it, then you have created a problem. So what we did is transform, recode into same variable. He said, I want the new variable that I've created. I can play with this, because the university one, the last one, is something that I created. I can go back and create another one. If we use this and say, listen, I want to merge al-balqa with just. So make number one the old value, which is number one. Now we remember this has values. If you remember here, al-balqa has number one, just has number 4. Okay, so I want to change, transform, recode into same variable, take the new variable that we've created, put it in the small box. Okay, now you hit old new values. The value that's number one, the old value, I want to change it into number 4. The value number one, which is Al-Balqa University, I don't want to have to deal with Balqa University. I want to say these students are just students. So take number one, convert it into number 4. Take Al-Balqa and convert it into just, continue, hit OK. The moment you hit OK, this variable will change forever. You cannot go back and undo what you did. So what happened here is it recoded university numeric number 1, shifted it into number 4. So number 1 shifted it into number 4. So Al-Balqa University now will be included as just students. If we do analyze descriptive statistics, frequencies, this is the new variable. Okay, there's no Al-Balqa University anymore. Everything has moved to just. all the students that had a record a value of 1 were converted into a value of 4. So these 116 students, which represent 8.3%, have moved from al-balqa into just. Al-balqa into just. Okay? So now you know what's the difference between data view, variable view, analyze, descriptive, frequencies. You can do analysis as you want. Okay? The last thing I want to show you is these are categorical variables that we've analyzed. Now, if I have a value or a variable like age, how am I going to analyze this? If you have age by, for example, 1 decimal point. So I am 40.2, 41.2, 43.5. You cannot create a simple table for this. This is called the continuous variable. Continuous variable is a variable that has decimal points, and these have meanings. So I've created what's called by negative emotions. Negative emotions here means all these emotions that I've asked for before here: depression, depression, worry, panic, loneliness, nervousness. I've just added them all together into a continuous variable. This continuous variable is called scale 1 negative emotions. If I want to do a frequency distribution for this, let's do a reset. Scale with S scale, okay. So if you go down here, or you stay all the way at the top, you hit S scale, because the name of the variable is scale, and it's also the label of the variable. So if you keep hitting S until you read scale, sorry, this is a scale. Scale 1. Okay. So this is what's called scale of negative emotions. Now, emotions, they have a value of 1, 2, and 3. 1 is decreased, 2 is neutral, 3 is increased. So the lowest participant scored 6, the highest scored 18. This is a fine table. You can present this as is, but it has no meaning because these numbers are really minimal. They're small. 10 participants scored 6, 6 scored 7, but I have the majority scored 18. Okay? So I want to do for this continuous variable, or for a continuous variable such as age. Now, a continuous variable is a variable that the numbers between any of its two values are in infinity. Okay, such as age. Age between the age of 20 and 21, the infinite number of ages, because you have decimal points. This is called continuous variable. Continuous variable, we do not perform frequency distribution. What we do is descriptive statistics, descriptives, I think. And here we want we said scale 1S. Scale 1. Okay. So for a continuous variable, we do analyze, descriptive, and then descriptives. It will give you the actual number, how many cases you have, how many participants, 14 or 4. Minimum score was 6, maximum score was 18. Mean was 14.07. Standard deviation was 2.1. Okay. Analyze. Okay. If we go back, hit analyze, descriptive statistics, descriptives, with this variable option, want the variance, range, standard error of the mean. Okay, it will give you all the statistics that you want, the minimum, the maximum, the mean and standard deviation, and the, sorry, mean and standard error, mean and standard deviation, and the variance. If you want to do it, make it more complicated, you go back to analyze, descriptive, explore, you hit scale. Actually, remove the scale one. And read here is still running the variable. Now, there are two things in SPSS. There's called data manipulation, where you start creating your own structure of the data, your own variable. For example, you have two questions, which is, do you smoke cigarette? Yes and no. Do you smoke water pipe? Yes and no. Okay. Now, I want to create a new variable that says, do you use tobacco? And this option, if you answer yes for cigarette and yes for water pipe, then you will have the term dual smoker. So if you answer yes for water pipe and yes for cigarette, the new variable will have you as dual smoker. If you answer yes cigarette, no water pipe in these two variables, the new variable will have you cigarette only. If you smoke only water pipe, no cigarettes, then the new variable will have you as water pipe only. Okay. And the last option will be no cigarette, no water pipe. So this is none. So I've created a new variable that's called tobacco use that reflects two variables. Do you smoke cigarette and do you smoke water pipe? So you can convert this using, we can address this next time, but you can create a new variable and then say if the answer for each one is yes, then this is dual use. If only cigarette, then this is only cigarette. If only water pipe, then only water pipe. This is why what we use what's called by data manipulation. So SPSS has two compartments. It has the data manipulation, which you can create variables, change variables, merge variables. You can do whatever you want, or you can just do the analysis. So here is the table that we created for this continuous variable. Okay, the mean is 14%. The standard 95% confidence interval between 13 and 14. If we trim 5% of the mean, if we take 5% of the readings, it'll be 14.1. The median is 14, the variance is 4, standard deviation, and minimum is 6, maximum is 18. Range, which is maximum value minus minimum value, interquartile range, Q3 minus Q1. Okay, so this will give you another option to look at variables that are continuous variables. If you have a variable like age, with age ranges between 18 and 40, and you have a large sample size, then probably each participant will give you an age that will not fit with others. So 14.5, 18 years 0.5 are going to be different than 18 years 0.6, 18 years 0.7. You cannot use a frequency distribution for continuous variables when you want to report them, unless they were just as little as I provided for this example. But you can give me an indication of their mean median, standard deviation, and look into these statistics. Okay? So I want you to go and play with the data, do some analysis at your own, look at the questions, and tomorrow we'll come back and do some more advanced analysis. Tomorrow we can look into the chi-square and the t-tests, chi-square and t-test, and see what can we analyze and make sense of this data, make more sense of this data. So far, it gives you an indication of emotional changes among medical students in Jordan. It gives you an indication about who participated in the survey, what school, what year, what university, what year of studies. And it gives you an indication about the emotional situation after the COVID around the area of March, mid-March to late March. Okay, so this was the lecture for today. If you have any question, just let me know. With SPSS, it's difficult to learn SPSS by just going to lectures. The best way is to use it. Once you remove the barrier between you and SPSS, and then you grab some statistics and you know what kind of tests you want, you can just Google it, go to YouTube. A lot of videos are there. You have this data set. This data set was collected from medical students. I provided the survey around 15th of March. You guys answered it. Most medical students answered it. So you know the survey. I can share the survey with you if you want. You know the questions, how the questions were answered, and then you have an idea about how I deal with what you have answered. So what you deal with is the front end of the data, which is the survey, and what I deal with is the back end, which is the actual data, and how we convert this data into more meaningful information. So instead of just zeros and ones and three and four and five, how we convert it into something that has meaning and something that medical schools in Jordan or deans of medical schools can consider when they're making decisions for what's called by emergency situations like COVID. Okay, so thank you very much, and I'll see you tomorrow at the same time.